This is about basic computer terms, which we need to know, maybe, because a lot of us are having to work with computers nowadays, and we never expected to, right? Harry here. Now, Harry happens to be a business person who's thinking of using a computer because he's about 90 years behind on filling his back orders. Enter Jane, the computer expert, who says, "I hear you need some help with computers." "Computers?" asks Harry. "Oh, yeah, computers. Say, listen, I know my business here. Even if I'm a little behind on the back orders, but nothing is what I know about computers." In fact, Harry doesn't even like computers. Maybe because he's seen all those old movies, you know, where the computer takes over the world. "Not to worry," says Jane. All a computer is, Harry, is a machine. A machine for handling information. "Jane," says Harry, "you're being very nice, and I appreciate it. But I've seen about these computer things. They are very big, very, very gigantic type things. I mean, you and me, they could eat for breakfast." "Harry," says Jane, "computers don't eat people. It's true, computers were very big in the old days, but that was before transistors, integrated circuits, things like that." Now computers come in all sizes, from large computer systems down to mini computers. In fact, you can already get a kit and build a simple computer yourself. "Well," says Harry, "I can tell you even that mini computer there has me scared." "What's to be scared of?" says Jane. "Look, let us go through this computer thing term by term, and we will find out it's not as bad as you think." "But why are we doing all this, Jane? What can this machine do that we can't?" "Harry, you're catching on. That's it. This machine cannot do anything that people cannot do. Or, to put it another way, people can do anything a computer can. Only the truth is, the computer can do it about a zillion times faster." "A zillion times faster?" says Harry. "With a zillion times faster, I could maybe even catch up on my back orders." "So, okay, how do we make this thing do whatever it does?" "First," says Jane, "you have to know the difference between hardware and software. You use the software to tell the hardware what to do." "Hardware," thinks Harry. "Hardware must be the computer itself and any of its parts, right?" "Right," says Jane. "And software is the instructions you give to the computer. Now, a computer program is a specific set of instructions for the computer. And a computer program is written in computer language, which just means to turn your instructions into a form that the computer can understand. And the person who writes that program, which could even be you, Harry, is called a computer programmer. Now, you put the program into the computer, and the next thing you put in is the information you want the computer to work with. And the term for that information is data. Now, the next thing to know, Harry, is that no matter how big or small a computer is, it has 4 basic kinds of devices in it: input, processing, memory, and output. The first are the input devices, which is where you put the information into the computer. The second are the processing devices, where the computer does most of its work. For example, it can organize information, or add, subtract, multiply, and divide numbers, or find important facts. The third are the memory devices, which store the information. And the fourth are the output devices, where the result comes out of the computer when you ask for it. Input, processing, memory, output, says Harry. How about that first kind of device there, asks Harry. You know, where the information goes into the computer. Sure, says Jane. Look, here's one of the most common input devices, the card reader. You use a card punch, this thing here, to put both the program and the data onto computer cards. A key punch operator types holes in computer cards, holes that represent letters or numbers. And a group of computer cards taken together is called a deck. Now, the deck of cards is loaded into the card reader, which shines light through the holes, see, thus putting the information into the computer. Another common input device is the terminal. Usually, a terminal uses a typewriter keyboard to put programs and data directly into the computer. And at the same time, the computer shows what is being typed. Sometimes it shows it on paper, and sometimes it shows it on a cathode ray tube, which we call a CRT for short. Okay, now, if there are no bugs in the computer program... Bugs, says Harry. Computers have bugs? I don't mean those kind of bugs, Harry. I mean bugs, which are mistakes in the program. Like when you give the computer the wrong instructions, the program has a bug in it. When you correct the mistake, it's called debugging a program. Okay, once the program is right, it's put into the computer. And next, you put the data into the computer. Then what happens, asks Harry. Then, says Jane, the computer goes ahead and does what you told it to do, which is called running the program. Okay, says Harry. I write the program in computer language. I put the program and the data into the computer, which then does what I tell it to. All this I got. But what does the computer actually do in there? You know, in its insides. It processes the data, says Jane, using its processing devices. Usually they're called Central Processing Units, or CPU for short. The CPU can process the data in whatever way you have programmed. Processes data, wonders Harry. What can this processing thing really do? Well, says Jane, for example, it can add up large numbers, or monitor vital functions of patients in a hospital, or rearrange composition of a newspaper page, or keep track of all sorts of information from many different people at once. Savings and loan banks, for example, use computers to calculate all the daily compounded interest for each and every depositor. So any customer can find out how much is in their account at any time. The computer does it automatically, without errors, and very, very fast. But Jane, asks Harry, how does a computer remember all this information? A string on the finger, maybe? With the memory, says Jane. Oh, yeah, the memory, says Harry. I forgot. All computers have a central memory for extra fast storage and retrieval of information. And if a computer needs more storage capacity, it can have other memory devices, such as this disk, which usually holds hundreds of times more information than the central memory does. A disk works much like a phonograph record, except that it uses magnetic coding. A magnetic tape can hold even more information than a disk, and it works very much like a tape recorder. Hey, says Harry, that's the kind I always see in the movies. Right, says Jane. It's a very common memory device, because it's so handy. You can take a tape full of information and put it away until you need it. Which you can also do with this. This, says Harry, this is just a plain tape cassette. Which, says Jane, records music on magnetic tape. Well, the same kind of cassette can be used by the computer to store programs and data. Okay, says Harry, we have this memory thing here, and it can store the computer program, and it can store the data. So then what? Output is what, says Jane. The computer will give you the result of what it has done through the output device. Now, the most common output device is the line printer, which prints the results on computer paper. Or the output can be in the form of magnetic tapes, discs, or cassettes. Or a terminal can be used as an output device. Wait a minute, says Harry. Wait a minute. Isn't a terminal an input device? Right again, Harry. A terminal is usually both an input and an output device, especially when you want to exchange information with the computer. Like an airline ticketing agent does, for example. First, telling the computer what flight the passenger wants. Then the computer telling the agent what's available. Then the agent telling the computer what flight, seat, and class to reserve. Then the computer confirming the reservation. And sometimes even printing a boarding pass right then for the agent to give to the passenger. Input, processing, memory, and output. Harry is beginning to get the hang of it all. But he's also wondering if all this equipment isn't pretty expensive. I mean, says Harry, a big computer like this must cost, what, $1 million? Well, says Jane, there are ways to keep the cost down. One way is to use a small computer, maybe even a specialized one, with a built-in program. Another way is to use a technique called time sharing. In time sharing, many different places and people use the same computer and at the same time. They may work from many remote terminals that can be far away from the computer's central processing unit and memory, but are linked together, often by ordinary telephone lines. Remote terminals can also be put into any office. Or if the user moves around a lot, there are portable terminals, which can be used any place where there is a telephone. But after all these basic computer terms, Harry is still worrying. Harry is a worrier. Listen, he says, if these machines do all this thinking, Harry, says Jane, computers don't think. It's us people who do the thinking. Computers simply process the data that you give them. And they process it in the way you tell them. The way I tell them? If this computer thing has to listen to me to know what to do, we may be in trouble in here. I'm no Einstein, you know what I mean? To tell the truth, says Jane, neither am I. But, it isn't all that hard. Almost anybody can learn to use a computer these days. Anybody, asks Harry. Anybody, says Jane. Well, the end of the story is that Harry thanks Jane for her help. and learns to use the computer terminal that is now right in his office, which helps him catch up on all those back orders and generally keep track of things much better than before. In fact, Harry is even thinking of cleaning up his office. Although you gotta remember, says Harry, you don't want to do too many new things at the same time, right? Right, Harry.